Welcome to this 8-minute presentation of the text protocol shim. First of all, I'm going to show you how the standard shim works. For this example, I'm going to take the SOAP shim. We have an XSD document that arrives in the subscriber channel. In the output transformation, this is converted via policies using often hard to understand XSLT. You can also specify to what node in the SOAP response you want your operation data appended to. The result is an XML file containing a SOAP document. This SOAP document is then, via the shim, passed to the connected system. The shim itself does not alter the SOAP document. It mainly handles the transport of the SOAP message via HTTP. When the shim receives the response back, the engine appends the operation data to the node you specified. Using some other XSLT, the developer needs to handle the operation data and convert the document to XSD. After this, the XSD can be processed by policies. The text protocol shim handles things completely different. The output transformation is not to be used for reformatting to SOAP. The XSD is submitted to the shim as is. It is the shim that contains the logic to convert the XSD to, in this example, SOAP. Any text format, such as JSON or plain XML, are also supported. For this, it starts by collecting the required data. Initially, this is only the XSD document received. The transformation of the XSD to the required format for the connected system, SOAP in this example, is done by using a template engine, Velocity. This enables you to create a template of the application-specific request and let the engine fill in the data coming from the XSD command. In this example, the result of the template processing is a SOAP request. The SOAP request is stored in the shim and submitted to the connected system. SOAP is typically transmitted using the HTTP protocol. Other protocols are possible. The term protocol needs to be interpreted very flexible. For example, the first release of the shim will also contain a script engine as protocol. This enables execution of arbitrary scripts generated on the fly by the Velocity engine to be executed on the remote loader server. When the system returns the SOAP response, this is added to the collected data. The shim will optionally parse the response so that it can be simply used in the template engine. For the moment, we support JSON, DOM document, and JDOM. Next, the shim will use the template engine again, but using a subscriber response template. All data collected can be used in generating the XSD. The generated XSD is actually a node set. It can, for example, contain one or more instance elements. This node set is wrapped in XSD response XML and returned to the engine, where it is processed like any other XSD result document, adding operation data at the usual place. On the publisher channel, the shim supports two modes of operation, triggered and polling. Let's look at triggered first. The connected system initiates a request, SOAP. The shim starts by collecting data. As on the subscriber channel, it first parses the request into an easy accessible Java object. Next, this is processed by the template engine, using the publisher request template. The result is again an XSD node set. This XSD is collected and submitted to the publisher channel. When the XSD is processed by the policies, we get the result back. This is added to the collected data. Using the fourth and last template, this is converted to a SOAP response and submitted back to the connected system. Besides the triggered flow, the text protocol shim also supports a polling mechanism. The publisher channel of the shim starts by periodically generating one or more XSD query documents. These queries are injected into the subscriber channel of the shim, where it is processed just like any other XSD command it would receive. It is processed by the template engine. You get a SOAP request, which is submitted to the application. You get a response back, which is parsed and processed by the template engine to return an XSD node set again. The publisher channel processes each element in this node set depending on the type of element. It makes a distinction between three types of results. First, it detects an XSD query element. It submits this back to the subscriber channel of the shim, where it is processed and submitted to the application. The use case for this are twofold. First of all, paged searches. Assuming that you poll for all user objects in the connected system, the connected system might not return them all at once, but return the result in pages. In order to be able to query back for the next page, the shim handles the query XSD element. The second use case for this XSD query element is for supporting querying for details. Assuming that your application has a high-level change log, you initially query for the list of changed objects. Then, for each result, the shim needs to query back for the new details of this object. This can be done using the XSD query element. The second element that is handled by the text protocol polling engine is the XSD instance element. For example, the polling queries for all users, and you get a list of users back, resulting in a list of XSD instance elements. These instances are handled by the publisher Delta processor. It starts with comparing the instance with the previous instance with this association it received. It generates a modify if it changed, or an add if it didn't receive it before. When the generated XSD query is processed, it also calculates and generates the XSD delete commands for every instance it didn't receive anymore in this polling cycle. These are all injected into the publisher channel. The third kind of XSD elements are all the other elements: add, modify, delete, move, and so on. These are injected into the publisher channel as is. The use case for this is if the connected system has an event log that is detailed enough, allowing you to generate the correct add, modify, or delete events directly from the polling results. I hope that this short overview gave you an initial idea of what the text protocol shim can do, what it supports, and how flexible it is. Thank you for watching.